So this is the 53rd session on relative velocity. In this session also I'll take up some problems on case 4 of relative velocity problems for translating frames. Now what is case 4 of the relative velocity? Case 4 has already been specified in the 42nd video on relative velocity. If you go to the 42nd video, you will get all the details of case 4. Okay, which problem come in case 4, that you will tell. You get in 42nd video. Okay, so I'll take up some questions on relative velocity case 4 in this 53rd session. Okay. A straight river flows towards east at a constant speed v naught with respect to ground. S1 and S2 are two swimmers whose swimming speed with respect to river is 5 v naught by 3 each. These two swimmers are initially at a point on south bank of the river, and begin to swim simultaneously across the river with constant respective speeds 5 v naught by 3 each. Swimmer S1 swims directly across the river. Swimmer S1 swims directly across the river to a point on north bank directly the starting point on the south bank. On the south bank. और अब फर्स्ट करो. ओके, starting point on the south bank. Swimmer S2 crosses the river in minimum time. दरवाजा भिड़का दोगी, दरवाजा भिड़का दो. Okay, fine. So in minimum time, and then walks the distance he has been carried by the river to reach the same destination as S1 at same instant. Find the walking speed of the swimmer S2 in terms of V0. Alright, this is the question. Fine, I'll rub it, okay? See, first I'll rub this also, okay? So first what I'll do, we'll identify all the objects and frames under consideration. So there are two objects under consideration, swimmer 1 and swimmer 2. Swimmer 1 will be denoted by S1 and swimmer 2 will be denoted by S2. Instead of M frame we have the river frame denoted by R. F frame we have the ground frame denoted by G. Alright. Now this is the top view of the situation. This is a straight river flowing towards east at a constant speed V0 with respect to ground. Suppose the river width is L0, it is not specified. I have assumed it. Okay. This you can do in problems. Sometimes this frequently happens that some data is not given, you can assume it. Okay, and if you correctly solve it, that will go away, it will cancel out. Okay, it will not come in the final answer. Now this is the south bank, this is the north bank. The two swimmers are both initially S1 S2 are at the same location on the south bank of the river. They both simultaneously begin to swim from this point from the same instant. Okay, S1 crosses the river in shortest possible directly swims across the river to a point on north bank just opposite to starting point on south bank, and S2 crosses the river in minimum time and then walks the distance that he has been carried by the river to reach the final destination at the same instant. Now we have to find what is the walking speed of swimmer S2 in terms of V0. So now the question is how to start to solve this question. From where do we begin? From where do we begin to solve this question? That is the main problem. Okay. So now the problem will be this. Suppose S1 takes T1 time to go from here to here, T1. And S2 also reaches the same destination at the same instant. So total time taken by swimmer S1 to cross the river is same as total time taken by swimmer S2 to swim across the river in minimum time and walk the distance to reach the destination, and both the times are same because they start from same instant and they reach the final destination at the same moment. So time of journey for both the swimmers are same. So T1 is the time of journey of swimmer S1 and T2 is the total time of journey of swimmer S2. So now what we must do, we must find the expressions for T1 and T2 and substitute in this formula, then we'll get the value of W, walking speed W. Okay. So first we find the value of T1. So T1 is the time taken by swimmer to swim across the river to a point on north bank just opposite to starting point on the south bank. So T1 is The swimmer S1 goes from this to this point at a constant speed, say Vs1g, and he moves a distance L with respect to ground. So time T1 becomes L upon Vs1g. Now to find T1, we must know Vs1g. Now to find Vs1g, we write down the vector equation. So Vs1g becomes Vs1r plus Vrg. That is how we write. Now Vs1r is nothing but vector. This we know the, now see, Vrg we know it is given V0 eastward, complete information given. Vs1r is 5 V0 by 3 given, but direction not specified. Vs1g we know only the direction from S1 to, from this point to this point, direction known but magnitude not known. Therefore it's this problem is, this part of the problem is a problem of case 3. So for find Vs1g we draw the vector diagram. Now to draw the vector diagram we first draw the arrows for Vrg and Vs1g with the tails coincident. So Vrg is in this direction V0, Vs1g is in this way, this is Vs1g. Tails of both the vectors have been made coincident. Now to draw the vector Vs1r, tail of this should also coincide with tail of these two, and it should be drawn on the side of Vs1g not containing this V0, that is on this side. So this is what, this is Vs1r, that is 5 V0 by 3. Now with these two as the adjacent side, we complete the parallelogram with this as a diagonal. Now we see that there are two right angle triangles. This is V0, so this is also V0, opposite sides of parallelogram. This is 5 V0 by 3. This is Vs1g, this is a right angle triangle. This is a hypotenuse, these are two sides. From Pythagoras theorem, what do we get? 5 V0 by 3 whole square is equal to V0 square plus Vs1g whole square. So Vs1g whole square becomes 16 by 9 V0 square minus V0 square. So 16 minus 9 is how much? Sorry, 25 by 9 minus 1 into V0 square. So this becomes 16 by 9 V0 square. So Vsg becomes what, tell me? Vsg becomes 4 by 3 V0. This is the value of Vs1g. So Vs1g becomes 4 V0 by 3. This is the expression for Vs1g. Alright. Now this side of it, okay? So Vs1g becomes 25 by 9 minus 1, 16 by 9. Alright. So what is T1? We have substitute Vs1g in this case. So T1 becomes how much? L upon 4 V0 by 3. So this becomes 3L by 4 V0. This is the value of T1, okay? T1 is equal to 3L by 4 V0. That is the value of T1. Now we have determined the value of T2. Now T2 is the time of journey of the second swimmer. So T2 can be broken into two parts. T2 is equal to T3 plus T4. What is T3? T3 is the minimum time in which the swimmer S2 crosses the river. Now it is given that swimmer S2 crosses the river in minimum time. So for minimum time will be when the heading of swimmer S2 is at right angles to river flow velocity. Okay, heading of swimmer S2 is at right angles to the river flow velocity. So T3 will be width of river L divided by Vs2r perpendicular. What is Vs2r perpendicular? Component of Vs2r perpendicular to river flow velocity. Perpendicular to river flow velocity, T3 is equal to L by Vs2r, where Vs2r perpendicular is the component of Vs2r normal to the river flow direction. Vs2r perpendicular is the component of Vs2r normal to the river flow direction, that is Vs2r perpendicular. Okay. Now this problem on this minimum time, this has already been covered in the 47th video. In 47th video, this information for minimum time is given. You can refer to that 47th video, then you will get this detail. So this I am directly using that result. Okay, you go to that video, you will get there. Now to know Vs2r perpendicular, so for minimum time we know that Vs2r should be in direction right angle to the river flow direction. So Vs2r perpendicular is simply this much. Vs2r itself, see this is the river, this is the river flow direction. In order to cross the swimmer river minimum time, so the heading of swimmer S2 should be in this way. This is the feet of swimmer S2, this is the head of swimmer S2. Okay, like this. Heading appears like this, see, it appears like this. This is how it appears. Like this. So Vs2r is in normal to river flow direction. So this Vs2r perpendicular is nothing but 5 V naught by 3 itself. Because this itself is at right angles to river flow direction. So this quantity itself is 5 V naught by 3. So T3 is how much? T3 is 5 V naught, T3 is equal to width of river L by 5 V naught by 3. So this becomes how much? 3L by 5 V naught. This is T3. Now what is T4? T4 is the time that the swimmer S2 walks on the river bank on the north side to reach the final destination of S1 at the same instant. Okay. So this I'll grab it, all right. So now we find the distance T to C. Swimmer S2 starts from here and comes here. The drift of swimmer S2 is say D. D is the drift of swimmer S2. Now swimmer S2 comes here and then he walks a distance D on the north bank to reach this point at a constant speed, say W. So let W be the constant walking speed of swimmer S2. W is constant walking speed of swimmer S2. So W is how much? Distance that the swimmer has drifted. S2 has drifted a distance D. So he walks a distance D on the north bank at a constant speed W. So that means T4 becomes D by W. D is the distance D that the swimmer S2 has drifted. That is also the walking distance. And divided by W is the constant walking speed of swimmer S2 on ground. Okay. So now to find T4 you must know D. Now what is D? D is the drift of the swimmer. You can again refer to the 47th video on relative velocity, 47th video. In that you get the 47th and 48th video, you get all the expressions for D also. 47th and 48th video if you go, you will get on relative velocity, you will get the expression for drift. So drift will be like this: component of VSG parallel to river flow direction into time taken T3 by the swimmer S2 to cross the river. That is equal to drift D. Now VSG parallel is what? Component of VSG along river flow direction. Now VSG parallel can be written in this way. VSG parallel, component of VSG along river flow velocity, that is VSG parallel. Okay, so D is equal to VSG parallel into T3. VSG parallel T3 is equal to D. So now what we do, that you can see this also discussed in the 47th video, 48th video, this information you will get for drift. Now in this case VSG parallel can be written in this way. Suppose unit vector along direction of river flow is even hat. So this can be written as, by component of vector theory, VSG dot even hat into T3. Okay, so VSG can be broken up as VSR, VS2R, this is S2. Okay, I'll just make it S2. Fine. This is just S2, not swimmer S1, but S2. Okay. VS2R plus VRG dot even hat into what? T3. Now VS2R is how much? VS2R is in this direction along, say, normal to river flow direction, say unit vector is E2 hat. So this will be written as what? 5 V0 by 3 E2 hat, and VRG is what? V0 even hat into dot even hat into what? T3. So this becomes E2 dot even becomes 0. 5 V0 by 3 E2 hat dot even hat plus V0 into even dot into T3. Now E2 and E are mutually perpendicular unit vectors. So dot product of two perpendicular vectors is 0, and even dot even becomes 1 by the theory of dot product. So this means D is just equal to V0 T3. And T3 we have already determined. How much was T3? T3 is equal to 3L by 5 V0. 5 V0 into 3L by 5 V0. V0 goes away. So d becomes how much? 3L by 5. Therefore, now we substitute d in this expression. So T4 becomes how much? D by W. 3L by what? 5W. This is T4. Alright. So T4 is equal to 3L by 5W. And D is equal to 3L by 5. And T3 is equal to how much? T3 is equal to 3L by 5 V naught. Now T3 plus T4 is just equal to T2, and T1 T2 are both equal as we discussed just now. So rub this one. Okay, fine. So what is T2? T2 is equal to T3 plus T4. T3 is how much? 3L by 5 V naught plus T4. How much is T4? T4 is 3L by 5W. And this is equal to T1 also, as we wrote initially, 3L by 4 V naught. So 3L goes away. So what we get is this 1 by 5 V naught plus 1 by 5W is equal to 1 by 4 V naught. Alright. So from this we can get W. 1 by 5W is equal to 1 by 4 V naught minus 1 by 5 V naught. This becomes 1 by 20 V naught. So 5W is equal to 20 V naught. So W is equal to 4 V naught is therefore the required answer. Okay. So answer is walking speed of swimmer S2 should be 4 V naught. That is therefore the required answer. So this should be the walking speed of swimmer S2, so that condition of problem is specified, satisfied. Okay. So this was a question on 53rd session. This was a question on case 4. Alright, fine. I'll rub this one. So this was the session 53rd. Okay. Now I'll take up another session on relative velocity, one more session. 54th session. In that also I'll discuss questions on relative velocity for case 4. Okay. So case 4, nothing can be said definitely. You have to observe the question, from there you have to decide. Alright. So I'll rub it. Okay.